NumPy is a fundamental library for high-performance multi-dimensional arrays and can be used for different mathematical functions like linear algebra, Fourier transformation, etc., and also for logical operations. Understanding this, we have come up with this tutorial on NumPy. Now, before we go ahead with the session, I'd like to inform that we have launched a completely free platform called Create Learning Academy, where you have access to free courses such as AI, Cloud, and Digital Marketing. You can check out the details in the description below. Now we'll start off with this library called as NumPy, which stands for Numerical Python. And as it is stated over here, it is the core library for numeric and scientific computing. So whatever numeric or scientific calculations you'd have to perform, NumPy should be your go-to language. And this library called as NumPy consists of multi-dimensional array objects and a collection of routines for processing these arrays. So let's go ahead and create our first NumPy array. So you can have a single dimensional NumPy array or a multi-dimensional NumPy array. Now we'd have to start off by importing this library. So to import NumPy, we'll type in import NumPy as NP. So this NP which you see over here is known as the alias. So we are importing the library NumPy with this alias NP. Now this NumPy library has a lot of methods, and one method is called the array method. And with the help of this, we will be able to create the NumPy array. All we have to do is type in np.array, and inside this I am passing in the list of values starting from 10 going on till 40, and I'll store it in this object called as n1. And when I print it out, I get the result 10, 20, 30, 40. Similarly, I go ahead and create a multi-dimensional array. So here we are passing in a list of lists. So here we had a single list. Here we are passing in a list of lists. So as you see, we have a list over here, and inside this we have two more lists. The first list comprises of the elements 10, 20, 30 and 40, and the second list comprises of the elements 40, 30, 20 and 10. And when I print it out, this is how I get this multi-dimensional array. The first list is present in the first row and the second list is present in the second row. Now let me go to Jupyter Notebook and implement these two. Let me just add a comment over here. I'll name it as NumPy. Now I'd have to import the NumPy library. So I'll have import NumPy as NP, and let's just wait till this library is loaded. Now that this is loaded, I can go ahead and create the NumPy array. So for this, I'll have to use np.array, and inside this I'll be passing in a list of values. So I'll pass in 10, 20, 30 and 40, and I'm storing it in this object called as n1. Now let me print out n1 over here. And as you guys see, I have successfully created this NumPy array, which over here the values are 10, 20, 30 and 40. And just to be sure, I'll go ahead and check the type of this NumPy array. So I'll have type. Inside this, I'll pass in n1, and as you guys see, we get the result numpy.nd array. So nd array stands for n dimensional array. Now we'll go ahead and create a multi-dimensional array over here. So to create a multi-dimensional array, we'd have to pass in a list of lists inside this np.array method. So I'll have this outer list. Inside this, I will create two lists. So the first list, let's say, comprises of the elements 1, 2, 3 and 4, and the second list comprises of the elements 4, 3, 2 and 1. Now I'll just print out n2 over here, and I have created this multi-dimensional array where all of the elements from the first list are present in the first row and all of the elements from the second list are present in the second row. Now that we have created these NumPy arrays, we'll now see how to create or how to initialize a NumPy array with different ways. So now let's say if I want to initialize a NumPy array with only zeros, then we have a method called as zeros. It's very intuitive, isn't it? So here we are importing the NumPy array, then we are using np.zeros, and it takes in two parameters. So these two parameters basically indicate the dimensions of the NumPy array. So if I want to create a 1 cross 2 NumPy array where all of the values are zeros, then I can just go ahead and type in np.zeros, and inside this I'll pass in the dimensions, which is 1, 2, and I get a 1 cross 2 NumPy array where the values are only zeros.
Similarly, over here, I am creating a 5 cross 5 numpy array where all of the values are zeros. So I'll just use np.zeros, and inside this, I'll pass in 5, 5. Now let me go ahead and implement this in Jupyter Notebook. Here, I'll add the comment np.zeros. Now I'll go ahead and let me just create this in n1, and inside n1 I'd have to use the np.zeros method, and over here I'd have to pass in the dimensions. So the dimensions would be 1, 2, and let me go ahead and print out n1 over here. So as you guys see, I have successfully created this numpy array. Now if I want maybe a numpy array with a different dimension, so the method would be the same. I'll have np.zeros over here, and inside this, let's say I want to create a 3 cross 3 numpy array which consists of only zeros, and this I'll go ahead and store it in this object called as n2. Now let me print out n2 over here, and we have a 3 cross 3 numpy array which comprises of only zeros. Now if I want to initialize a numpy array with the same number, then we can go ahead and use the full method. So here I am using np.full, and this takes in 2 parameters. The first parameter is the dimension of the numpy array. The second parameter is the value which we'd want to insert into this numpy array. So here we are creating a 2 cross 2 numpy array where the value is filled with 10. So as you guys see, it's a 2 cross 2 numpy array where we only have tens. So it's time for np.full. I'll just type in np.full. I'm adding a comment over here. Then let me add np.full, and I'd have to give in 2 parameters. Let's say I'd want a 4 cross 8 numpy array, and I'd want the value 5 inside this. Now I'll store this in this object called as n3, and I'll just print out n3 over here. And as you guys see, I have created a 4 cross 8 numpy array where the value is only 5. Similarly, if I want to initialize a numpy array within a particular range, then I can go ahead and use the arange method. So here, as you guys see, I am using np.arange, and this again takes in 2 parameters. The first parameter is the initial value from which the range has to start. So here when I give in 10, as you guys see, the range starts from 10. And when I give in 20, so here again you'd have to remember that 20 is exclusive, or maybe the second parameter is exclusive. And since this is exclusive, we'll only have values starting from 10 and going on till 19. And that is why 20 is not included in this result over here. Now we can go ahead and add another parameter. So here the initial value is 10, the final value is 50, and we have the skip value. So the skip value is 5, which would mean that after 10 we'll have 15. So 15 plus 5 becomes 20, 20 plus 5 becomes 25, and that is how this keeps on proceeding. Now when we reach 45, when you add 5 more to 45, that becomes 50. And since 50 is exclusive over here, that is why we end at 45. But on the other hand, if we had given the final value as 51, then we would also have the element 50 over here. So let's go ahead and implement arange method over here. np.arange, and I'll store this in n4. Now I'd have to use np.arange, and I'll go ahead and give in the initial value as, let's say, 100. Then I'll give the final value as 200, and I'll print out n4 over here. And as you guys see, we have all of the numbers in sequence starting from 100 going on till 199. Now if I actually want the value 200 to be included in this as well, let me make the final value to be 201. And as you guys see, this time the range starts from 100 and also includes 200 over here. And we can also add a skip value. Now let's say if I give the skip value of 10. So here after 100 we have 110, then 120, and this goes on till 200. Now instead of 201, if I keep the final value as 200, we see that this numpy array ends at 190 because 200 is exclusive. Now we can also go ahead and initialize a numpy array with random numbers. And to initialize numpy array with random numbers, we can use random.randint. So here we are invoking np.random.randint, and over here we have three parameters. And over here we have three parameters. The first parameter is basically, and over here we have three parameters. The first two parameters basically indicate the range from which we would want the random numbers. So we would want the random numbers in this range of 1 to 100. And this third parameter would tell the Python interpreter how many random numbers do we need. So in the range of 1 to 100, we would need 5 random numbers. And as you guys see, this is the result which you get over here. So we have 95, 88, 26, 22 and 76, which are 5 random numbers generated between the range of 1 and 100. I'll add this comment random. Now let's go ahead and initialize a NumPy array with some random numbers. So I'll have np.random.randint because I want a random set of integers, and this will take in 3 parameters. Let's say I would need values between 50 and 100, and I would need 10 random values over here. And let me store this in N5. Let me go ahead and print out N5 over here. And as you guys see, I have 10 random values which are generated between the range of 50 and 100. Now, similarly, if I go ahead and run this again, I'll get a different set of values. As you guys see, we have a different set of values again. When I click this, we again have a different set of values. That was all about initializing a NumPy array with different methods. Now you can also go ahead and check the shape of a NumPy array. And to check the shape of a NumPy array, we have the shape method, which again is very intuitive. So here we are creating a NumPy array where we are passing in a list of lists. So in the first list we have 1, 2 and 3. In the second list we have 4, 5 and 6. So obviously we will have a NumPy array where we'll have 2 rows and 3 columns, and this is what the n1.shape gives us. Now if we want to change the shape of this, then we can use the same method. So here what I'm doing is I'm typing in n1.shape and I'm changing the shape from 2, 3 to 3, 2. That is, instead of having 2 rows and 3 columns, I will have 3 rows and 2 columns. So this same shape method can be used to check the shape of the NumPy array and also reshape the dimensions of the NumPy array. So let me create a NumPy array over here. So we would have to create a multi-dimensional NumPy array. So this will be n6 is equal to, I'll have np.array, and inside this I'll have to create a list of lists. So in the first list I'll have values 10, 20 and 30. And in the second list I'll have values 40, 50 and 60, and I'm storing this in n6. Now once that is done, let me just print out n6 over here. So you guys can see this NumPy array. Now I'll also go ahead and check the shape of it. So I'll have n6.shape, and we get the result that this is a NumPy array where we have 2 rows and 3 columns. Now I can also go ahead and change the shape of this. So I'll have n6.shape, and over here I am changing the shape to be equal to 3, 2. Then I'll go ahead and print out n6. And as you guys see, we have converted this from a 2 x 3 NumPy array to a 3 x 2 NumPy array. So you had 10, 20, 30 in the first row. We've got 10, 20 in the first row here. So similarly, this is how this has been changed. Then we have some stacking methods over here. We have vstack, headstack and column stack. So let's just start with vstack. So we are creating a NumPy array n1 where we have the values 10, 20 and 30. Then we are creating the NumPy array n2 where we have the values 40, 50 and 60. Now when we use vstack over here, this again takes in 2 parameters where we'll just pass in 2 NumPy arrays inside this. So as you guys see, we are vertically stacking over here. So when I say vertically stacking, I have one NumPy array on top of another NumPy array. So because I'm using n1, n2, n1 comes at the top, n2 comes at the bottom. So this is how vertical stacking works. Then we can also go ahead and horizontally stack 2 NumPy arrays. So n1 and n2, we've got the same numpy arrays over here. And instead of using vstack, I'm using the head stack method. I'm passing in n1 and n2. And as you guys see, 40, 50, and 60. So n2 has been stacked horizontally to n1. Then we have the column stack. So if we want to stack these numpy arrays into separate columns, so we have n1 and n2, and when I'm using column stack over here, as you guys see, n1 goes into the first column, n2 goes into the second column. And this is how we can work with these stacking methods. So I'll have to create these two numpy arrays over here. I'll have n1, which will be np.array, and inside this I'll have 1, 2, and 3. Then I'll also go ahead and create n2. So this will be np.array, and inside this I'll have 4, 5, and 6. So I have my n1 and n2 ready. Now I'll start off with vertical stacking. So I'll use np.vstack, and inside this I'm passing in n1 and n2, and let's see what would be the result. So we have vertically stacked n1 with n2. n1 is at the top, n2 is at the bottom. You can also change how these are stacked. So instead of giving n1, n2, let's say if I give in n2 and n1, you guys would see that n2 is at the top and n1 is at the bottom. Now we can similarly work with the head stack method. So here I'll type in np.hstack, and inside this again I'll pass in n1, n2. And as you guys see, I have stacked n2 at the back end of n1. Now, if I want n2 first and n1 second, I just have to change the sequence. So inside np.headstack, I'll give in n2, n1. And I have 4, 5, 6 first, and n1 is attached at the back end of n2. Then we have column stack. So I'll just have np.column stack over here, and inside this I'll pass in n1, n2. And as you guys see, I have n1 in the first column, n2 in the second column. Similarly, if I give in n2, n1, you will see that I have n2 in the first column and n1 in the second column. So this is all about stacking the numpy arrays. Now we'll also work with intersection and difference methods. So here again we have two numpy arrays. So in the first numpy array we have the values from 10 to 60, and in the second numpy array we have the values from 50 to 90. And if I want the common elements between these two numpy arrays, then I can use the intersect 1D method. So here in the intersect 1D method, I would just have to pass in these two numpy arrays, and as you see in the result, we get a new numpy array comprising of the common elements in these two numpy arrays. Then over here I have n1 and n2. If I want to find out all the elements which are unique to n1, then I can use the setDiff1D method. So here in n1 we have the elements starting from 10 going on till 60. In n2 we have elements starting from 50 going on till 90. So here as you guys see, 50 and 60 are common in n1 and n2. And if I want the elements which are unique to only n1, then I would have to use setDiff1D, and I'll pass in n1 and 2. As you guys see, I get only 10, 20, 30 and 40 because 50 and 60 are present in both the numpy arrays. I can also change the sequence over here. So instead of passing in n1, n2, when I pass in n2, n1, then this will give me all of the unique elements which are present in n2. And since 50 and 60 are common in both the numpy arrays, the resultant will be 70, 80 and 90 because these are the only unique elements in n2. So let's go ahead and work with intersect 1D and setDiff1D. I'll just add a comment over here, intersect 1D, and I would have to create two new numpy arrays. I'll have n1 over here. So I'll have np.array, and inside this I'll pass in 1, 2, 3, 4, 5, 6, and I'll have n2, and inside this I'll go ahead and create a list of elements where the elements start from 5, 6, 7, 8 and 9. So I have these two set over here. Now that my two NumPy arrays are ready, if I want to find out the common elements which are present in these two NumPy arrays, I'd have to use intersect 1D. So I'll have np dot intersect 1D, and inside this I'm passing in n1 comma n2, and when I hit on run, we see that the common elements between n1 and n2 are 5 and 6. Now if I want only the elements which are common to n1, then I can use the setDiff1D method. So here I'll have np dot setDiff1D, and inside this again I'll be passing in n1 comma n2, and as you guys see I have 1, 2, 3 and 4 which are common to only n1. Now similarly, if I want all of the elements which are only common to n2, then I can have np dot setDiff1D, and I'll just change the sequence over here. Instead of passing n1 comma n2, I'll have n2 comma n1, and the only unique elements which are there in n2 are 7, 8 and 9. Now we'll go ahead and perform some simple NumPy array mathematics. So we'll see how to add two NumPy arrays. So again over here we have two NumPy arrays. In n1 we have 10 and 20, in n2 we have 30 and 40. Now if I want the total sum of all of the elements which are present in both of these two arrays, I can just directly use the sum method. So I'll have np.sum, and inside this as a list I'll pass in n1 comma n2, and you will see that the resultant value would be 100 because 40 plus 30 plus 20 plus 10 is equivalent to 100. Now if I want to find out the individual sum along the rows and along the columns, then I can use the additional parameter called as axis. So if I want to sum the values along the column, then I'll set the axis to be equal to 0. So when I have the axis value to be equal to 0, as you guys see, I have 30 plus 10 equal to 40 and 40 plus 20 equal to 60. Similarly, if I want to sum these up along the rows, then I'll set the axis value to be equal to 1. And over here I have 10 plus 20 equal to 30 and 30 plus 40 equal to 70. I'll add a new comment over here, addition of NumPy arrays, and let me create new n1 over here. So I'll have np.array, and inside this I'll have 10 and 20. Then I'll go ahead and create n2, and inside n2 I'll again have np.array, and over here I'll have 30 and 40. I'd have to pass this on as a list of values, so I'll have 30 and 40 inside a list. So I have created n1 and n2. Now it's time to find out the total sum which is present along all of these. So I would have to use np.sum, and inside this I'll just pass in n1 comma n2, and actually I'd have to pass this as a list. So I'll have n1 comma n2 over here, and as you guys see, the resultant comes out to be 100. If I want to add the values along the column, so I'll have np.sum, then I'll have this list over here, I'll have n1 comma n2, then I'll have this new attribute called as axis, and I'll set the axis value to be equal to 0. And I get the resultant 40 and 60 because 30 plus 10 is equal to 40 and 40 plus 20 is equal to 60. Now going ahead, if I want to add the values along the horizontal rows, so here it will be np.sum, and over here I'll have n1 comma n2 again, and this time I'll set the axis value to be equal to 1, and I have 30 and 70 because 20 plus 10 is equal to 30 and 40 plus 30 is equal to 70. Now we'll see how to do some scalar operations on these NumPy arrays. So here we have a NumPy array where we have values 10, 20 and 30, and if I want to add the scalar value 1 to each individual element of the NumPy array, all I have to do is add this value 1 to this NumPy array, and as you guys see, n1 plus 1 becomes 11, 21 and 31. Similarly, if I want to multiply each individual element of a NumPy array with a particular value, so here if I want to multiply it with 2, I'll just write down n1 into 2. So 10 becomes 20, 20 becomes 40, and 30 becomes 60. And if I want to subtract a value, all I have to do is perform n1 minus 1. So 10 becomes 9, 20 becomes 19, and 30 becomes 29. And if I want to divide it, I'll just have n1 divided by 2. So 10 becomes 5, 20 becomes 10, and 30 becomes 15. So this was some basic idea about NumPy. Now let me just see what is there in n1 over here. Let me actually add some more elements inside this. So I'll have n1 is equal to np.array. And inside this, I'll have 10, 20, 30, and 40. Let me also print out n1 over here for your reference. So now that we have n1, what I can do is I will just go ahead and add some scalar values to it. And let's say if I want to add 5 more to each individual element of this NumPy array, so I'll just write down n1 plus 5. And as you guys see, 10 becomes 15, 20 becomes 25, 30 becomes 35, and 40 becomes 45. Similarly, if I want to subtract a value, I'll just write down n1 minus 5 over here. And 10 becomes 5, 20 becomes 15, 30 becomes 25, and 40 becomes 35. We can also go ahead and multiply something to this. So I'll have, let's say, n1 into 10. Let me print this out. And as you guys see, we have multiplied these values with 10. Similarly, I can go ahead and divide this with something. So if I have n1 divided by 10, so we see 10, 20, 30, 40 becomes 1, 2, 3, and 4. So this is some basic scalar operation on top of the NumPy arrays. And we can also go ahead and use some mathematical functions. So we have this mean function over here, which would give us the mean value of all of the elements which are present. So the mean value of all of these elements comes out to be 35. Similarly, if you want to find out the median, then all we have to do is use this median method. We have to use np.median, we'll pass in this NumPy, and we see that the median value comes out to be 55.5. And if you want to find out the standard deviation, I'd have to use std, and I'm passing in n1 inside std, and the value becomes 36.59. So we have n1 over here, and if I want to find out the mean value, I'll just have np.mean, and inside this I'll be passing in n1. And as you guys see, the mean or the average value of all of the elements which are present in n1 comes out to be 25. Let me go ahead and create another NumPy over here. So I'll have np.array, and inside this I'll be passing in some random values. So let's say these are all of the values which are present in n2. And if I want to find out the median of all of the values which are present, so I'll just use np.median method, and inside this I'll be passing in n2. And the median of all of these values comes out to be 5. Similarly, if I want to find out the standard deviation, so here I'll have np.std. And if I want to find out the standard deviation of this particular NumPy array, so I'll pass in n2, and you would see that the standard deviation of all of the elements of n2 would be 2.397. So till now we've worked with some basic NumPy arrays. Now let's go ahead and work with a NumPy matrix. So here we are creating a 3x3 NumPy matrix, and to do that you'll again need a list of lists. So over here we'll have 1, 2, 3, 4, 5, 6, and 7, 8, 9. So this first list goes into the first row, second list goes into the second row, and third list goes into the third row. Now that we have created this NumPy matrix, let's see how can we access individual rows and columns from this entire NumPy matrix. So here, let's say if we want to access the first row, again you'd have to remember that the indexing in Python starts from 0. If we want to extract the entire first row, we'll just have n1, and inside parenthesis we'll pass in 0. And as you guys see over here, I have successfully extracted the entire first row. Similarly, if I want to extract the entire second row, then the index value for second row will be 1, and I have extracted the second row. And if I want to extract a column, then I'd have to do something like this. So in a column, I would want all of the rows. So here from this NumPy matrix, I would want the second column and all of the rows from the second column. So here, since I would want all of the rows, I'll just put in a colon over here, and since I want the second column, I'll give in the index value as 1. And as you guys see, I have extracted the entire second column over here. Similarly, if I want to extract the entire third column, the index value will be 2, and I have extracted the entire third column. Let's perform this in Jupyter Notebook. So I'll just write in NumPy matrix over here. Now that this is set, I'll have np.array, and over here I'll have a list of lists. So in the first list I will have 10, 20 and 30. In the second list I will have 40, 50 and 60. In the third list I will have 70, 80 and 90. And I will go ahead and store this in N1 again. Now I'll go ahead and print out N1 and let's see what would be the result. So this is our NumPy array which we have just created. Now if I want to access individual rows from this, I'll have to give in N1, and inside parenthesis, let's say if I want to extract the third row, then the index for the third row will be 2. I'll just have 2 over here. And as you guys see, I have successfully extracted the entire third row. Now similarly, if I want to extract the entire third column, then this time I would have to write N1, and over here, since I would want all of the records from the third column, so I'll just have a colon over here, then over here. So here you'd have to understand whatever is given on the left side of the symbol would indicate rows, and whatever is given on the right side of this comma would indicate all of the columns. So I'd want all of the rows, and all of these rows need to be from the third column, and the index for the third column is 2. And I have successfully extracted all of the elements which are present in the third column. Now we'll see how to transpose a matrix. So what is transposing? Transposing basically means when you're interchanging the rows and columns. So here, as you guys see, we have 1, 2, 3, 4, 5, 6 and 7, 8, 9. Now the rows should be interchanged with the columns. So here 1, 2, 3 which is present in the first row comes into the first column. 4, 5, 6 which is present in the second row comes into the second column. 7, 8, 9 which is present in the third row comes into the third column. Let's go ahead and perform transpose as well. So all I have to do is use np.transpose, and inside this I'll just pass in n1 over here. So as you guys see, initially I had 10, 20, 30 which was in row. This became in column. 40, 50, 60 was in second row, became the second column. 70, 80, 90 was the third row, which became the third column over here. Now we'll see how to perform two matrices. So over here we have N1 where we have the elements starting from 1 going on till 9. Then we have N2 where we have elements starting from 9 going on till 1. Now if we perform the dot operator on this, which is basically matrix multiplication, this is how the multiplication happens. So the multiplication is row by column, which would basically mean, so here we have 1, 2, 3, here we have 9, 6, 3. So it will be 1 into 9 plus 2 into 6 plus 3 into 3, which will give you a result of 30. Then again we'll have row by column. So here it will be 1 into 8 plus 2 into 5 plus 3 into 2, which will give you a result of 24. Then it will be 1 into 7 plus 2 into 4 plus 3 into 1, which will give you a result of 18. And this is how this progresses, and finally we'll get this result over here. And the dot product of n1 into n2 and n2 into n1 will be different. So as you guys see, this is the dot product of n1, n2, and this is the dot product of n2, n1. Both of these will be different. So I already have n1 over here. Let me go ahead and also create n2. So here I'll write n2 is equal to np.array, and over here I'll have the elements in reverse order. So I'll have 90, 80, and then I'll have 70. Going ahead, I'll have 60, 50 and 40. After this, I'll have 30, 20 and 10, and I am storing this in this object called as n2. Let me also go ahead and print out n2 for you guys over here. So this is what we have. Now if I want to perform the dot product, so I'll have n1. I'll actually have, if I want to perform the dot product here, I'll have n1 dot dot. Inside this, I'll pass in n2. And as you guys see, this is the dot product of n1 cross n2. But we know that n1 cross n2 and n2 cross n1 is different. So when I perform n2 dot n1, the result will be different from n1 dot n2. So this was about matrix multiplication. Now we'll go ahead and see how can we actually save a NumPy array and then load it from somewhere else. So here we are creating this NumPy array where we have elements from 10 to 60. Then to save this NumPy array, we just have to use the save method. And over here we are saving this NumPy array with this name called as my_NumPy. So this takes in two parameters. First parameter is the name by which we'd want to save this NumPy array. Second is the array which we'd want to save. Now once that we save this, to load this NumPy array, we will have to use np.load, and over here we'd have to give in the name by which we save this NumPy array. So we save this NumPy array as my_NumPy, and we'd have to give the extension which is .npy, which basically stands for NumPy, and we go ahead and store this in n2 and we print out n2. We see that we have successfully loaded this NumPy array over here. Now I'll go ahead and save this. So I'll have np.save, and this, as we have seen, takes in two parameters. The first parameter is by which I save this. So I'll have save n1, and I would want to store n1. So I have saved this. Now if I want to load this, I would have to use np.load. And over here, I'd have to give the name of the NumPy array. So it will be save_n1.npy. Let me actually remove this over here. And I will store this in, let's say, n9. Let me click on run over here. So we have an error over here. We have this error because I'd have to give this inside single quotes. Now if I click on run, we'll get the result. Now if I print in n9 over here, we finally get the result.
This brings us to the end of this tutorial on NumPy. Before you guys sign off, I'd like to inform that we have a free learning platform called as Great Learning Academy, where you have access to multiple free courses. So thank you very much and have a great learning ahead.